252 million years ago, a catastrophe so devastating it killed 95% of all species on Earth unfolded in the geological equivalent of an eyeblink, leaving behind only a thin black layer of rock as evidence. Scientists have discovered we're now releasing carbon at rates that echo those ancient volcanic eruptions, which raises the question: are we unwittingly recreating the conditions of Earth's greatest mass extinction? The ocean floor turned black, not slowly over millions of years, but in what Earth scientists call the blink of an eye, just a few thousand years. A dark layer of mud spread across the seafloor like a giant blanket, burying countless sea creatures. This thin, dark line in the rocks tells us about a time when life on Earth almost ended. It happened 252 million years ago, in what we now call the Great Dying. This was the worst disaster life ever faced, killing 95 out of every 100 sea animals and 7 out of every 10 land animals. Almost everything died. If you could travel back in time to just before it happened, you'd see oceans teeming with strange creatures. There were trilobites, bug-like animals with hard shells that had lived in the seas for 300 million years. Huge sea scorpions, longer than a tall person, hunted in shallow waters. On land, forests of giant ferns and ancient trees spread across the continents. Strange reptiles and amphibians, some as big as cars, roamed these forests. But something was stirring deep in the earth. In what we now call Siberia, the ground began to crack open. Lava poured out, not for days or weeks, but for thousands of years. The eruptions covered an area bigger than all of Western Europe, with layer upon layer of black rock. The smell of sulfur filled the air, burning the lungs of any creature that breathed it. With each eruption, invisible gases rose into the sky: carbon dioxide and methane, gases that trap heat like a blanket, built up in the air. The world began to warm, slowly at first, then faster. The seas soaked up this carbon until they couldn't take any more. The water turned sour like vinegar. Sea animals trying to grow shells found them melting away as soon as they formed. On land, the air grew thick and hot. Plants that had thrived for millions of years began to wilt and die under skies that turned the color of rust. The temperature rose higher and higher, first by 5 degrees, then 8, then 10. In the hottest parts of the world, animals literally cooked inside their shells and skins, unable to cool off. And as seas warmed, they lost the oxygen that animals needed to breathe. From the deep waters rose clouds of poison gas, hydrogen sulfide, that smells like rotten eggs. This gas kills even in tiny amounts. The oceans turned from blue to purple as strange bacteria that don't need oxygen took over. When this poison reached the air, the sky took on a greenish tint. The whole world began to smell like rotten eggs, the scent of death. In rock layers from this time, scientists find pollen from plants that cause fungal infections. With plants dying, fungi took over, feeding on the dead and dying. The world was becoming a place where life could barely hang on. What could survive in such a world? And more troubling, are we creating similar conditions today with our own carbon emissions? The world was dying, and it started in Siberia. If you stood there 252 million years ago, you'd see the ground splitting open. Red-hot lava poured out day after day, year after year. It wasn't just a few volcanoes. It was like the earth itself had cracked open. The lava spread over an area bigger than France, Germany, and Spain put together. Even today, you can see this hardened lava. It's called the Siberian Traps, and it's over 1 million cubic kilometers of rock, enough to cover the entire United States, half a mile deep. But it wasn't the lava that killed almost everything. It was what you couldn't see, the gases. Each eruption sent huge clouds of carbon dioxide and methane into the air. These gases work like a blanket. trapping the sun's heat. At first, the warming was small, just 1 degree, but it kept building as more gas poured out. Soon the world was 5 degrees hotter, then 8, then 10. That might not sound like much, but it's enough to change everything. The oceans soaked up much of this carbon dioxide, the way a sponge soaks up water. This made the seas turn sour like lemon juice. If you were a shellfish back then, your shell would start to dissolve. Imagine if your bones began to soften and your teeth started to crumble just because you were breathing. That's what happened to many sea creatures. On land, the heat became unbearable. If you walked through a forest that had stood for millions of years, you'd see leaves turning brown and falling. The sky above had a strange color, like rust or copper. It was harder to breathe as the air grew thick with carbon dioxide. The ground became dry and cracked as water evaporated in the heat. Animals tried to escape. If you could watch from above, you'd see reptiles and amphibians moving north, trying to find cooler places. But there was nowhere cool enough. Many animals simply cooked in the heat. Scientists have found fossils that show animals in positions of panic, as if they were running when they died. Then came the worst part. As the seas got warmer, they lost their oxygen. Fish and other sea animals couldn't breathe. From the deep parts of the ocean rose a deadly gas called hydrogen sulfide. It smells like rotten eggs, and even a small amount can kill. The seas turned from blue to a sickly purple as new bacteria took over, ones that didn't need oxygen to live. This purple ocean released more hydrogen sulfide into the air. If you looked up, the sky would have a greenish tint, like when a storm is coming, but this storm never ended. The whole world began to smell like rotten eggs. Plants couldn't grow in this poisoned air. Animals couldn't breathe without being hurt. Scientists studying rocks from this time find something strange. The rocks themselves smell bad when broken open, even after 252 million years. The poison from that ancient disaster is still trapped inside. The world had become like a planet from a scary science fiction story, except this really happened. And as our own world warms from the carbon we release, the question becomes, could it happen again? A few animals found ways to live through the great dying, but only by changing how they lived. Our oldest ancestors, small furry animals called synapsids, had one lucky skill. They could dig. As the world above grew too hot to live in, these little creatures dug holes and went underground. Deep in their burrows, the temperature stayed cooler and more steady. They slept more to save energy. Their bodies got smaller, needing less food in a world where plants were dying. Scientists call this the Lilliput effect, named after a story about tiny people. Animals that once were as big as dogs shrank to the size of mice. If you could dive into the dying seas, you'd find one group of shelled animals called ammonites barely hanging on. They looked like today's nautilus, a spiral shell with tentacles sticking out. Before the disaster, there were hundreds of different kinds of ammonites in all sizes. After, only a few types survived, and they were all much smaller. These survivors learned to swim between the poisoned deep water and the slightly better water near the surface. They became experts at finding tiny pockets of oxygen in a sea that was choking to death. On land, the world became eerily empty. Where once thousands of different animals lived, now only one kind took over. It was called Lystrosaurus, a plant eater about the size of a pig with a turtle-like beak. It wasn't special or particularly strong. It just happened to be tough enough to survive when others couldn't. After the Great Dying, 95 out of every 100 land animal fossils we find are Lystrosaurus. Never before or since has one animal so completely taken over the world. If you tried to dig down through rock layers from this time, you'd find something strange, a gap where fossils almost disappear. Scientists call this the dead zone, and it can be hundreds of feet thick in some places. This empty layer represents millions of years when life was so rare that almost nothing was preserved as fossils. It was as if Earth held its breath for millions of years. But very slowly, over thousands and thousands of years, things began to improve. The massive volcanoes in Siberia finally stopped erupting. Without new carbon dioxide constantly pouring into the air, the weather began to cool. Rain falling on rocks started a chemical process that pulled some carbon dioxide out of the air like nature's own cleanup crew. The green-tinted, sulfur-smelling skies gradually cleared. In the seas, the toxic purple bacteria began to die back as oxygen slowly returned to the water. The oceans shifted from purple back toward blue. Though the process took thousands of years, life, which had been holding on by a thread, began to spread out again. The few surviving plants started to multiply. Animals that had been hiding began to venture out and find new places to live. For the tiny mammals hiding underground and the few sea creatures that survived in the least toxic waters, the world was opening up again. It was empty, waiting to be filled. And from these few survivors would come all the animals we know today. The biggest mass extinction had created the biggest opportunity in Earth's history, a fresh start for those tough enough to have made it through. When life finally returned after the Great Dying, the world was different. The creatures that survived found an empty planet, like a blank page waiting for new stories. The small, rat-like synapsids that hid underground during the worst times would eventually give rise to all mammals, including humans. Without the Great Dying, we might never have existed. The empty world created winners and losers. A new group of reptiles began to thrive in this reset Earth. We call them dinosaurs. They filled the spaces left behind by all the animals that died. For the next 185 million years, dinosaurs would rule the world, all because of the opportunity created by the greatest disaster life ever faced. Today, scientists study this ancient catastrophe by looking at rocks. If you visit certain places in China, Italy, or South Africa, you can see a dark line in the rock layers. This thin band marks the time of the Great Dying. If you touch this dark layer, you're touching a moment when life nearly ended. If you strike the rock with a hammer, it sometimes still gives off a faint smell of rotten eggs, the ancient poison trapped in stone for over 250 million years. The Great Dying teaches us that Earth's story isn't smooth and steady. Instead, it's long periods of small changes interrupted by sudden, huge disasters. These moments reset life's path, like wiping a game board clean and starting over with new players and new rules. What's most troubling is that the disaster that nearly ended all life looks a lot like what's happening today. The Siberian volcanoes released massive amounts of carbon dioxide, warming the planet. Today, we release carbon dioxide by burning oil, gas, and coal. The ancient world saw oceans turn acidic as they absorbed carbon dioxide. Our oceans are growing more acidic each year. The ancient disaster saw oxygen levels drop in the seas. Today, we find growing dead zones in our oceans where oxygen is too low for fish to survive. Scientists have even detected rising levels of the deadly hydrogen sulfide gas in some parts of our oceans, the same poison that turned ancient skies green. The biggest difference is speed. What took thousands of years during the Great Dying is happening in decades under human influence. We're releasing carbon dioxide about 10 times faster than those ancient volcanoes did. We're warming the planet at a rate not seen in millions of years. The dark layer in the rocks isn't just a record of an ancient disaster. It's a warning. It shows us how thoroughly life can be wiped out when the carbon cycle is severely disrupted. It took 10 million years, that's 10,000 years, for life to fully recover after the Great Dying. That's more than 1,000 times longer than humans have had civilization. When you see smoke from factory chimneys or car exhaust pipes, you're watching carbon dioxide enter our air, just as it did from those ancient volcanoes. The ocean floor hasn't turned black again. Not yet. The sky hasn't turned green with hydrogen sulfide. Not yet. But as we look at that thin, dark line in the rocks, we must ask ourselves, are we creating the conditions for another great dying? And if we are, do we have the wisdom to change course before it's too late?